Baker Botts, LLP, provides podcasts for educational purposes only. They are not legal advice and are not intended to establish an attorney-client relationship. This communication may constitute attorney advertising.
Welcome to AI Council Code. The AI Council Code is here to keep you up to date on all AI legal issues arising in the modern business frontier. I'm your host, Maggie Welsh, and today we're going to switch things around a little. I'm going to turn the mic over to my partner, Mark Spiegel, who's an IP partner in the Austin office. Mark had the privilege of sitting down with Dr. Pablo Rivas, who is a computer science professor at Baylor University and an expert on large language models, and they were able to discuss all things AI. Mark and Dr. Rivas had such a good conversation that their conversation will actually span 3 podcast episodes. So in this first episode, Mark and Dr. Rivas discuss what is AI and how do we define the generative AI that we see today in the mainstream. So let's tune into their conversation now.
This is Mark Spiegel. I'm an intellectual property attorney with Baker Botts. I specialize in managing risks with intellectual property and handling disputes. And I'm happy to be hosting our AI podcast today, where we're going to be interviewing Dr. Pablo Rivas from Baylor University, who is an expert in large language models and specifically in the neural networks used for ChatGPT and things like that. So Dr. Rivas, could you please tell us a little bit about yourself?
Hi, I'm happy to be here. Thanks for the invitation. I've been working in the space of AI for over 18 years, probably. It's something I'm very passionate about, and I really enjoy how things are moving forward in the space of AI. Sometimes I think it's too quick, but I started working this almost exclusively during my master's degree and PhD program at the University of Texas in El Paso, and then as a faculty member, continued research in that for the last few years. I've been working both with computer vision applications and language modeling until this whole thing exploded with ChatGPT. And also we were looking at ethical considerations of AI technology, and that also had tremendous implications in the last 5-6 years. So I had a lot of work.
All right, so jumping in here, you used the term in your intro, and I'd love to hear you just give a little bit more of a definition of what does AI even mean when you use that term?
Well, in IEEE, for example, which is an organization that brings together engineers of different disciplines, and defining AI, it's a problem. Also for ACM, who is in charge of the computer scientists and computing technology, also has struggled with defining what AI means. So right now, what I'm about to say is kind of the today definition of what people would understand by AI. So they usually divide it in 2 things: narrow AI and wide AI. By narrow, people usually mean very specific AI that's applied to specific problems, like a neural network that does recognize your voice, or there's a statistical inference combined with data and learning algorithms to make a decision for a bank or a self-driving car. So it's very narrow AI that does something specific.
Let me pause. You said statistical inference. Can you explain what that means?
It means that it combines data analytics, like looking at what is the most likely outcome of a particular scenario based on data, and combines that with existing knowledge that was learned through a neural network, for example, and provide a decision based on that.
So that's what you'd call narrow AI when you have enough kind of technical background in neural network learning to use some statistical information and make decisions based on a set of facts that the narrow AI is encountering. Is that right?
Right. So it is very, very specific, oriented, application specific, and even the AI or the machine learning pieces behind it could be different across different applications. So AI involves machine learning, deep learning, statistical learning, and data mining as well. So those are the things that people call AI today. Now, wider AI is bigger AI concepts that involve making much more difficult decisions and considerations, different types of data. There is a field that is called general artificial intelligence, and that is the idea that there is some kind of super intelligence that can be achieved that could be put together by using smaller or more narrow AI, put together in a big picture sort of thing. And so that is a kind of AI we're talking like sci-fi movies, Terminator. If you're remember that. So in that movie, there was one AI that controlled several parts of information, technology, and pieces of that kind of bigger super intelligence. This is a wider AI. And that's usually not what people mean when they talk about AI today in 2024.
Are those technically similar fields, or are they pretty different technology when you're talking about narrow AI versus wide AI and versus general AI from the movies?
It is very different to the point that when we have conferences in the field of AI, we almost exclusively have those separate. It is rare that you will have a conference when both groups are in the same place. And most of the work that is being done today in the last 5-10 years is being on narrow AI, very application specific. But now that the field is settling a little bit and that we have very good AI for very specific things like language models or computer vision models, then we're starting to think big picture, what is next? And then that's when the other group will come into play.
Let's talk about some of those specific applications you mentioned. What is a computer vision application?
Computer vision is something that's trying to imitate the vision system of a human being, usually, or other mammals, something that has eyes. And so the idea is that through a computer program, usually that has machine learning or AI behind it, is trying to simulate how an eye would process information and get to a point where that information is useful for a specific task. So a good example is most smartphones today, that if you take a picture of a QR code, you'll be able to understand that pretty easily. But that's the easy part now. The harder ones are if you take a picture of shoes, then you can actually identify what kind of shoes they are and trigger a search online for those specific shoes and see if you can get them somewhere. That's an example of computer vision, but other computer vision that is not something very accessible to a day-to-day human being could be interpretation of X-rays or other three-dimensional imagery or medical images, satellite images.
When you say interpretation of X-rays, do you mean interpretation of the scan that the doctor is looking at on the side, or do you mean interpretation of like a sensor that's actually receiving X-ray radiation?
The interpretation of the X-ray is in the form of pixels of a data file that usually a radiologist today might use to confirm their diagnosis or their observation. I'm pretty sure the X-ray person doesn't make the diagnosis. I think that's a doctor, but the person that takes the X-ray makes notes, and that's when AI could assist that person in confirming the findings and also the doctor in interpreting those findings. So that's something that would look at those pixels and that information and give us something. And that's the process of a doctor. The doctor looks at those pixels or that image of an X-ray, and it will make a decision based on that.
So I think the other example you mentioned was a large language model. And this might be something people have heard a little bit about in terms of ChatGPT, but can you explain more from a technology standpoint what the large language model is?
Large language model, well, we'll start without the large. A language model is a machine learning model. There are different types of language models that don't necessarily use AI. They could be probabilistic. And the reason for that is because a language model is simply something that will predict the next word in a sequence of words. And in theory, it's dictated by probabilities. So if you have enough data that you are able to take a sequence of words and predict the next one in the sentence with high accuracy, then you could, in theory, have a model that can finish or complete your sentences or respond in a way that is likely to sound like a human is writing.
But you would still call that a probabilistic model?
It is still probabilistic.
And how is a probabilistic model different from a model that uses AI?
Well, AI learns the probabilities or learns to model those in a way. But AI really comes down to learning vectors and weights and biases, we call those, but really vectors that contain some type of knowledge in there that contains enough information so that if you bring an input, like a question, that the model will be able to take that question, transform it into vectors, multiply it by some of the vectors, and predict with high probability the sequence of words that will respond to that question. But it's nothing more than the best prediction of that sequence of words. And that's one of the points of contention that I have to people who use language models in general, that some people believe that the language model is some sort of database, but it's not. It's just trying to give people something that looks like a human would say it. And so based on the training, the question that you're asking to a language model was in the training data, and the answer was there too, chances are that the model would probably be able to reproduce that answer and give it to you. But it doesn't mean that the language model is a database. It's just learned to produce that sequence of words with high probability.
That's great. And I think that's a really important distinction to understand, that we're used to computers being this repository where you save information in your computer and then you go retrieve it with a command. And from our conversation so far, it sounds like that's not the right way to think about a large language model or any kind of language model, that it's not saving the contents in the repository. It's learning how to recreate those similar output. Is that right?
That is correct. And one of the big problems we have today is that, specifically now talking about the large language models, they are large because now those vectors are huge. We're talking a model that is worth gigabytes, and that is crazy for us to imagine that 5 years ago. That was completely out of the picture. We were talking a model that was 140 or 240 megabytes 5 years ago, and that was really cool. We're all very excited, but now we have models that are terabytes. They have trillions of tokens, and tokens means really how much vocabulary they can handle. And so the contention with these large language models is that, number one, we don't know exactly what is going on inside, and it seems like it's memorizing things. But we know from past experience that it's not supposed to be able to memorize things verbatim, but what it's memorizing is probably a way to reproduce things or sentences exactly like in the training data.
Well, that's all we have time for today. Stay tuned for part 2 and 3 of Mark and Dr. Rivas's conversation. And thank you again for listening to the AI Council Code. We're so glad that you joined us today. Stay tuned for additional podcasts and more insights on AI legal issues.
Thank you for listening to this BakerBots podcast. BakerBots has the experience, knowledge, and people to address our clients' most significant legal issues. For more information on BakerBots practices, please visit us at bakerbots.com. This presentation is provided by BakerBots LLP for educational and informational purposes only. It is not legal advice and is not intended to establish an attorney-client relationship. Under the rules of certain jurisdictions, this communication may constitute attorney advertising.